Here we have a GRE question where you are trying to solve for a scenario where x is y% of x squared. Now, taking a look at the problem, this is one of the comparison problems that GRE students just love and adore. Sheer sarcasm there. But we're going to take a look at the information that's given and see what we can do. Looking at the first two statements, x and y are integers greater than 5. Okay, that's great. It doesn't tell you that much information, but you do know at least that x and y are not negative, and they are any positive integer 6 and up. Then we have the second statement, x is y% of x squared. So let's write that out. X is equal to y% of x squared. Notice how I transferred the verbiage into mathematical operations. Is becomes my equal sign, percent becomes my percent sign, of becomes multiplication. If we want to put this in terms of just x and y, so that they're on separate sides of the equal sign, then we can go ahead and divide the right side by x squared. That cancels out our x squared on the right, leaving us with y% is equal to x over x squared, which is just x. So x is equal to y%. Percent means out of 100. So essentially this is y over 100 if we were to get rid of that percent sign. If we want y by itself, we just multiply the right side by 100 and the left side by 100, and we get y is equal to 100x, which means that as long as x is over 5, y satisfies at least the first statement. Now, let's take a look at the numbers that we were given. I say with the comparison problems, you always want to look at your extremes because that will help you to identify whether or not the relationship can or cannot be determined. If x is 6, we're going to look at the numbers 6, 10, and 100. Now, I chose these numbers because 6 is greater than 5 but less than 10. 10 would mean that the two quantities were equal, and then 100 would mean that x is greater, and these are all with respect to x. So if we plug in 6, that means that 6 is greater than 5, and if we plug in 6 for the second term, or second statement, we get 6 is equal to y% of 36. Then we would divide this by 36 to get y by itself, and we would get 6 over 36. And if you don't want to do that in your head, you can just plug it into a calculator, and that would give you 1/6, right? So let's go ahead and simplify this into 1/6, and as a decimal that would obviously not be greater than 5, so that's not possible. Let's pick 10, for example. Oh, and actually, one other thing. We need to multiply that by 100. So if we then multiply that by 100, there we go. Now it's possible. 16.6 is equal to y. Okay, so that satisfies both parameters. Let's take a look at 10. If we use 10, we really only need to focus on the second equation. So we put 10 in there, so 10 is equal to y% of 100, 10 squared. So we divide this by 100, we get 1/10, but then we're going to multiply it times 100, and we're going to get 10. That would make y and x both equal to 10. Okay, so far we have 6 that works, 10 that works, and what about 100? If we were to take 100 and plug it in for x, let's use green here, we'd get 100 is equal to y% of 10,000. We would then divide both sides by 10,000, and we get 1 out of 100. But then we're going to go and multiply it times our 100, and we would get y is equal to 1. That would not make y greater than 5. But if we chose a slightly smaller number, let's just cover our ground and take a look at the number 20, for example. That would give us 20 is equal to y% of 400. We would then divide both sides by 400 and then multiply it times our 100 to get 5. So it's equal to 5 but not greater than 5. So we covered most of our ground, but just to double check, let's take a look at 30. I normally would not say plug in all these numbers, especially on the GRE where it's timed, but this is just so for learning purposes. If we were to take 30, we would get, I'm going to kind of squeeze it in the top here, we get 30 is equal to y%, and remember it's 30 squared, so that would be of 900. We would then divide our 30 by 900 and then multiply it times 100 to give us 3 1/3. So as we get bigger, the y values don't work. But we have two answers that work. Either B is correct, where column B is greater, so 10 is greater than x, and that we saw when x was equal to 6. But it also worked when x was equal to 10, and therefore the relationship cannot be determined. So you, in fact, don't even really need to check the numbers that are greater because you already have two parameters that work. Just for comfort purposes, it's always good to check all of the extremes, which is why we went ahead and did them all, and also for learning purposes. But because B satisfies everything and both quantities being equal satisfies everything, our best option is the relationship cannot be determined.